Okay, this is part 3 of the notes for 3A, and I got another question for you. What's the best angle to approach any challenge? The triangle. So let's go over this example here. We're talking about angles of elevation and angles of depression. So first thing you should do is just read through the problem, see what they're asking. So a princess is on top of a 167-foot tower looking down at a 37-degree angle of depression at a present attached to a rope on the ground. How long is the rope? Okay, so we've talked about before, like on the triangle when I'm looking for things, this would be like the ground, this would be like a hill, or in this case a tower, and then this is her line of sight down to the present. So the first thing it tells us is that the princess, I'll just label that with a P up here, is at the top of a tower that's 167 feet. Okay, so there she is standing on the tower. She's looking down at an angle of depression, 37 degrees. So you have to remember she starts out this way, and then when she looks down, that's my 37 degrees angle of depression. Down here, there is a present, okay, attached to the rope. That's 37 degrees depression there. The question is, how long is the rope? This is the rope here. The rope is going to be connected to the tower down to the present. So now, to solve this, we have to recall that the angle of depression and the angle of elevation inside the triangle is 37 degrees. They are going to be the same. So when I look at the parts that I have in comparison to the angle of 37, this is the opposite side, and this is the hypotenuse. That indicates sine. Sine of 37 degrees equals the opposite over the hypotenuse. Okay, so since x is on the bottom, this is a divide problem. We're going to take 167 divided by sine of 37 degrees. When I do that, I'm going to get 277.5, and this is also in feet. That makes sense that it's longer than the tower. The hypotenuse has to be longer than the side. So there's that answer. That is the length of the rope. One last example I'd like to go through is go ahead and pull up your practice for this. We're going to do number 1 together here. So on all of these, I've just given you kind of a generic triangle, and you can use that triangle to fill out any of the given information, and then that helps you determine what trig you're going to use. It does say in the directions, angles should be rounded to the nearest degree and sides to the nearest tenth, so depending on what you're looking for. So let's take a look at the first one. A 15-foot tree casts a 12-foot shadow. Okay, so just similar to what we've done before. These would be the things on the ground, like a shadow, or from the base or something like that. That is 12 feet. Things going up and down right here that are going vertical, like a tree or a building or a hill, that's going to be on that side there. And it wants the angle of elevation to the sun. So like the sun is up here. Okay, this is the angle of elevation, and that's what we're trying to find. So to set up our trig, we use the same ideas. This is the opposite side. This is the adjacent side. So that indicates tangent. So the tangent of some angle, we'll label x in this one, is going to equal to the opposite side over the adjacent side. Anytime we want to find an angle, we are going to use our inverse trig button. So this is inverse of tan. So on your calculator, you're going to push second tan. You'll see how you get that little -1, that's a little inverse. Then we're going to let the calculator do our division, 15 divided by 12, and that is my angle. So again, you have to use, whenever you're trying to find an angle, you have to use the inverse button. Okay, so it says to round the nearest degree, so angle x would be about 51 degrees. Okay, so that should give you a good start on the angles of elevation and depression. As always, let me know if you need any help. Bye-bye.